Hi, everybody. I just want to go over a few of the blood typing problems with you and a few of the dihybrid problems with you just to make sure that everybody's on the same page. And then I will be posting like an answer key for both of them in just a little bit. So I'm just going to flip this around and go through some of these problems with you. So, this first one right here, mom has O blood type, and then dad has O blood type. What's the blood type of their children? I mean, I don't know about you, but that one was like really super easy because the only possibility they could have is little I. So, what the blood types will be for their children, all their kids can only have O blood type. O blob. Oh my god, I can't smell. Blood. O type O blood. Mom has A blood, dad has B blood. Their daughter has O blood type. How is this possible? So for this one, number one, is it possible? Yeah, it is. And if I look back at this little chart right here, I know it's a little different than how we were doing it, but the only way that they could have a daughter with O blood type is if both mom and dad were heterozygous, meaning, so mom is type A, she's AI, and then dad is type B, BI. And then when you plug it all in together, there you go. What is the chance of them having a child with type O blood? 25% chance of type O. You see that? Sorry, of type O blood. So you can see that's the only possibility with those two genotypes. And when you fill in the Punnett square for that. If we just kind of keep going down on the page, a man is homozygous for type A blood, has a baby with a woman who is A hybrid. Hybrid means heterozygous. What are the possible genotypes for the baby? So if dad is homozygous for type A, the only possibility he could have is big A, big A. And then if the woman is A hybrid, which is heterozygous, she's A little I. And then if we plug all of this in, this is that. This is what are the possible genotypes? So 50% AA and then 50% chance of AI. Both of them, I mean, no matter what, they're going to have a kid with a type A blood type. But for genotypes, one would 50% chance of having it heterozygous, 50% chance of having homozygous. If we go on with the problems, a homozygous B man has a baby with an O female. What are the possible genotypes? So homozygous B, big B, big B, little I, little I for the woman. And then the only possible genotypes for their child would be, so it's all big B, little I. So that would be the genotype. What would be the phenotype of this? It would be type B blood. Okay, moving on. To number 5, a it says heterogeneous. I hope you caught that and thought, oh, she must have meant heterozygous because that's what I meant. Sorry about that. Heterozygous, A male and female have a baby. What are the possible genotypes? So that means that they're both heterozygous for A. And then if you plug that in, what are the possible genotypes? So 25% big A, 50% big A, little I, and then 25% little I. That would be the possible genotypes for that one. Hopefully you're kind of getting the hang of this. Number 6, a man who is homozygous A has a baby with a woman who has O blood type. They have a baby who also has O. Is this possible with these two parents and their genotypes? So a man is homozygous A, big A, and then with a woman who is little I for O blood type. If you fill that all in, Is it possible that these two parents could have a child with O blood type? No. The only possibility that they would have is type A blood. So this is where you can use like this is a paternity test to determine help determine who is the father. This would be you are not the father. Okay, I'll do one more of this, but I think that you guys hopefully kind of got the hang of it. Is there a hard one on here? I don't know. These bottom ones here, don't worry about doing those if you didn't do them because those are, I know, hard. A man with O marries possible. Woman with A. Yeah, we kind of did one. A child has O blood type. His mother is B and father is A. The brother is A and B blood. So let's do number 11. Is it possible that these two parents with type B blood, type A blood could have an O blood type child and an AB blood type child? Is that possible? Well, let's try it. If both parents are heterozygous, um, yeah, they could. There was a 25% chance of them having type AB blood, a child with type AB blood, and a 25% chance of them having a child with type O blood, and then 25 for A blood, 25 for B blood. So that works for that one. Okay, like I said, I'll post an answer key for this just so you guys all can see that. Now for the dihybrids, let's move to that one. Come on here. When you do, I'll post an answer key to dihybrid crosses too. Don't worry. But I want to go through at least a couple of these. It says a man has a genotype of big B, big C, little c. So brown eyes and curly hair are dominant. The B's are going to be for eye color. C's will be for hair color. List the 4 possible sperm cells that this man could produce as a result of meiosis. So basically, what I'm asking in the second bullet point here are what are the gamete combinations where you have to foil it. So if you do big C or big B, big C, and foil this all out. So the first would be big B, big C, outer, big B, little c, inner, little b, big C, and last would be little b, little c. So that's what would be right in here. Those would be the 4 possible gamete combination. Then it says, suppose the man from question 1 marries a blue-eyed woman with straight hair. Blue eyes and straight hair, those are both recessive. So the woman's genotype, she'll be little b, little c. And so her gamete combinations is going to be the same for the whole thing all the way down. So then what you're going to do is take these and plug those into a Punnett square. I'm going to show you a trick. So yeah, I said the 6 or the dihybrids, it's 16 squares. But when you look at this, big B or the little b, little c, you technically only have to write it once. You would get the same ratios, get the same numbers, and you only have to write it once. You can do the whole 16 square Punnett square, but you don't have to. Okay, so to set this up, then I am. So now this is how I would set up the dihybrid Punnett square. I put all of the man's possible genotypes up here, and then the woman's I just put right here. And yeah, you could do little b, little c going all the way down, but it just would get really repetitive, and you will still get the same ratios if you just do it once. So when I combine this, it would look like this. Little c. Those would be the possible genotypes for their children. So it says list the ratio below. How many brown and curly? Well, when I look at this brown and curly right here, this is brown and curly. So 25% is brown and curly. I'm going to make a little mark there to just make sure that I got that. 25% is brown and straight. 25% is blue and curly. That would be that one right there. And then 25% is blue hair and straight. So that is that one. So it would be like a 1 to 1 to 1 to 1 ratio on that. So that would be that one. So the dihybrids, that is like the trick, that's the shortcut. You don't, if there are similar gamete combinations, like all of these were big B or they were little b, little c, you can just, you only have to do like the one gamete combination just like once, like I did here. But if they're all different ones, you have to do that for all of them. Okay, I'm gonna do this next problem right here. A right-handed brown-eyed man, heterozygous for both traits, marries and mates a woman with who is right-handed and blue-eyed. She is homozygous for both traits. Okay, so for that one, I'm gonna use R's and I'll use B's again. So right-handed is gonna be dominant. So the right-handed brown-eyed is heterozygous for both traits. So I'm gonna go big R, big B, little b, crossed with mates with a woman who is right-handed and is blue-eyed and heterozygous for both. So big B, or actually I did R's first. So big R for right-handedness, and she's homozygous, and then blue-eyed little b, because that's the recessive. That would be hers. And so if I did then the FOIL to all of those, or to each of those, this would be, so I'm just going to write it here, big R, big R, little r, big B, little r, little b. That, and they're all different, so we have to use all four. And then for this one is big R, little b, big R, little b, big R, little b, big R, little b, big R, little b. So again, this one is only going to be just going for across. And if I combine this, it would look like that. So then if I answer the questions, was there a question? Oh, list the phenotypic ratio in the space below. So when if I would write the phenotypic ratio, I would say, so this one is right-handed brown eyes, right-handed brown eyes. So two right brown to, so this is right-handed blue to two right blue eyes. So that would be the phenotypic ratio for that. Okay. I will post the answers for the last two problems. I'll get that posted on Classroom for you. If you do have questions for how to do the dihybrids, or I know I just kind of showed that shortcut. Maybe some of you saw that and were doing it. Maybe not, but you can use that shortcut if you want. We will have more practice. I hope everybody has a great spring break and that you all relax and enjoy yourself. Hopefully we have some nice weather. And yeah, miss you guys. See ya.